All right, we're going to look at our sum and difference formulas. I'm going to break it into 2 videos, so to see the exciting conclusion, you'll have to watch the next video. But let's get started right away. So here we are. We're going to look at a unit circle. And if everybody remembers, a unit circle is a circle whose radius is 1. So if we were thinking about this ordered pair right here, we would know that that was 1, 0, since this has a radius of 1. I'm going to draw in a few angles here. We'll call this first one, and we'll call it V because convention tells us that's what we usually do. That's what mathematicians like to call it. So on most of the formulas, you'll see it as V, so we'll call it V also. And we'll label this ordered pair. We don't know what it is, so we'll just give it a name. I'm going to call it XY, but you can call it whatever you like. I'm going to pick another angle. We'll call this angle U, because again, that's usually what they call it in the formulas, so we'll call it U also. And this ordered pair, we could call it X sub 1, Y sub 1. You see that a lot, but I'll just call it A and comma B because I think when you get all these X's and subs and whatever, it gets confusing and sometimes people leave them off by accident. So we'll just call it AB. It doesn't matter again. All right, now what I'm going to do is I'm actually going to, from here, I'm going to move up V. So I'm going to make an angle that's V units big. So imagine that this angle and this angle were perfectly the same size, which in my picture I can tell obviously they're not quite the same, but let's pretend that they are. So let's say that this is angle V right here, right? So this is the same size as this one. So this angle would be, well, if I went all the way around, it would be U. And if I backed it up V, degrees or V radians or whatever you want to call it, then this would actually be U minus V. Does that make sense? So this angle is actually going to be U minus V because I've made this little angle V units big, and this one would have been U if we went all the way around. So if I take out that V part, it's U minus V. Okay, so good. So far, so good. We'll call this one something, I guess CD is as good as anything. We'll call that one CD. Okay, so there's my picture. I'm going to draw one more picture over here. It's actually the same picture, but this one is going to be too confusing to look at if I draw a ton of stuff on it. So let's just draw a new one. All right, so once again, this one we know is 1, 0. This guy over here was CD. This one over here was XY. And this one over here was AB. Okay. Now I'm going to make some chords here. I'm going to connect these ones and these ones. Now from geometry, we know that, these chords they subtend the arc of a circle, whatever. They could be different lengths. They could be all different sizes. But in this particular picture, they happen to be the same size. And we know that because take a look at this picture. This one, this arc, that's the beginning and the end of this chord, is the same as this arc here. And how big was the angle inside there? Do you remember? It was U minus V. So the angle, the central angle that we have here, creating this arc, is U minus V, right? Well, take a look at this one. So the blue one here, that's this arc here. Sorry, this one here. So I'm just making it nice and thick so you can see, but obviously I'm talking about that arc there. Okay, that one, if we went all the way from here to here, we agree that it would be U, right? Because that's angle U. But I didn't go all the way from the beginning. I cut out this little V piece. So do you see how this blue arc, the angle that, the central angle here for this blue arc would also be U minus V? So if the angle lengths are the same, that means these arc lengths are going to be the same. And it also means that these chords are going to be the same. So we know from geometry that these chord lengths are going to be the same size. So what I'm going to do is I'm actually going to make an equation that says that those chord lengths are the same size. And how do you find length if you're sitting on a coordinate plane? Well, you use distance formula. So that's what I'm going to do. I'm going to say the distance of this chord and the distance of this chord are the same. So how do I get started? I'm going to say C minus 1 squared. And this one is D minus 0, right, for the y values, D minus 0 squared. The square root of that, so that's the distance here. The square root of that has to be equal to this distance if what we just said was true, and it is. So it's going to be x minus a squared plus b minus y squared. Square root of that. Now we're just going to do one more thing, and then we're going to stop, and we'll do the rest on the next video, but let's just do one more thing here. Let's actually start talking about this in terms of trig, because right now we have no trig in this, right? And we're trying to do the sum and difference formula for our trig. So let's take a look. Let's draw a triangle here. And this would be x, and this would be y. So let's talk about the cosine of v. The cosine of v would be, we said this is a unit circle, so the hypotenuse is 1, would be x over 1. So hopefully you can see that cosine v is actually just x, because x over 1 is the same as x. So if x is equal to cosine v, that means I could change this x to cosine v. And sine v is going to be y over 1. So you can see that sine v is actually the y, or in other words, y could be written as sine v. And if that's true, then that means that this one is going to be cosine u, comma, sine u, by the same idea. And this one is going to be cosine u minus v and sine u minus v for that ordered pair, C and D. So what I'm going to do is I'm actually going to change these C's and D's and A's and B's and X's and Y's. I'm going to change them to sines and cosines. So this C becomes cosine u minus v squared. Well, not squared yet, I guess. We still have to do minus 1. That whole thing squared. Plus, the D becomes sine u minus v. And if I subtract 0 from it, it stays the same. So it's going to be that whole thing squared. Square root of that is equal to, well, the x I'm going to change with cosine v. The a I'm going to change with cosine u. And the b I'm going to change with sine. I should have done them both the same. Let's make it yb just to keep them sort of the same. It doesn't matter that much, but why don't we do that? Just for clarity, how's that? But it doesn't matter which way we do it because they're going to be squared, so it makes little difference. I guess I should have done it just because, left it alone because I had already written it. But sine v minus sine u. But this way maybe we won't get ourselves as confused just because they're in the same order. Okay, so there's our distance formulas with the sine u's, sine v's plugged in instead. Now what I'm going to do in a second, I'm going to stop the video and I'll do the rest. We'll simplify this ugly thing in our next video. Okay, so hopefully you aren't too confused. And again, if you had left it the other way, it just would have transferred these, but when you square it, you're going to see it comes out the same. So it doesn't matter which way you wrote them. You're going to be fine either way. Okay.